Hello everyone, welcome you back for the engineering graphics session. In this, the module 1 consists of the introduction to the computer aided sketching. The computer aided sketching consists of the three part. The first part is with respect to the basic instruments, and the second part is with respect to the conventions, letterings, and also the dimension. The third part is with respect to the coordinate systems, and the last part is the same thing with the use of the computer. Now, before going into the engineering graphics or it may be the engineering drawing in detail, first we will go with respect to the some codes and why we have to learn the engineering graphics and what is the need of the engineering drawing. With respect to that, the first thing is plan your work and work your plan. The drawing is a vision on the paper. It means that any drawing to analyze, you should know all the symbols, or it may be the line representation, or it may be the dimensions, or it may be how it is to be read and what are the details it fetches to implement the component. Here in this case, in this slide, there are what we can say the three sketches are there. The first one is nothing but indirectly what we can say a plan. A plan consists of so many things, which is some 2 3 lines. A boundary will be there, and inside some cross mark, and so many symbols are represented. What these indicates, if you know these things only, then only it can be read and it can be analyzed very easily. The second one is it is something like a sphere shaped some component is there. For that also the drawing is there. For drawing, even there also the dimensions it is been represented. Above that, a what we can say the raw material drawing is also mentioned. Now, technical drawings allow the efficient communication among the engineers and can be kept as a record of the planning process. Why means because in the sketch what we can say the two lines are not joined properly. These type of errors will happen once if the drawings is not proper. Now, the drawings are of two. In the previous maybe 10 years back, we used to draw by using the manually. Now, most of the drawings are drawn by using the computers and as well as the software related programs. Now, the drawing instruments. Drawing instruments are some of the scale, protractor, compass, set square, drawing pencils, sharpeners, erasers, and as well as the mini drafters, or even the tri squares are also used as a basic tool for the engineering drawing. Now, coming to the drawing sheets, drawing sheets are having a specified size and as well as a dimension. Most of the times we know only the A4 size sheet, but it starts from A4 and it ends at A0. Uh, A4 twice is nothing but A3. A3 twice is nothing but A2. A2 twice is nothing but A1. A1 twice is A0. Like that, the shape and size of the what we can say the sheets also vary with respect to the A0 to A4. A4 is the smallest and A0 is the largest. Now coming to the letterings, writing letters using the drawing instruments will consume a lot of time. So the lettering should be done in freehand sketching using the guidelines. See here there are first of all before drawing any drawing we have to go for the type of the pencil or the leads what we are using it. Even there also now the leads is varying from H to B. Normally we have seen only the HP pencils. The H series is nothing but the light series, or the what we can say the hardness is more. B series are nothing but the darkened leads where the dark drawings can be drawn, which is nothing but the softness. The here in this case A B C D E F, these six letters which has been represented, and the space consumed by each letters is of different. but all the letters will have a same size. Even the size is also matters with respect to the engineering drawing. Now, the types of projection. The types of projections are the single view projection and as well as the multi view projection. The single view projections are perspective projection, oblique projection, axonometric projection. Axonometric is classified into dimetric, trimetric, and isometric. The multi views are orthographic. Even in the orthographic also, it has been classified into first angle projection and as well as the third angle projection. Now what we are referring is with respect to the first angle projection, but in the previous 10 years back we used to refer the third angle projection. Now before going with respect to the drawing, the objects drawn with their true size is called as the full size drawing, where the size or the scale what we are using is nothing but 1:1. It is not possible to draw the bigger object or the machine parts and the sheets. In that case we have to go for the reducing scale, which is nothing but what we can say, the reduction scale we have to use it, and then afterwards we have to draw. There's another concept which is nothing but a small objects, either it may be something like a watch needles. These dimensions are of very small in size. These dimensions, it has to be represented on the paper, is also difficult. In that case what we are using is nothing but the enlarged scale. Indirectly what we can say, the scale is nothing but the drawing dimension to the actual dimension, which is also called as representative factor. Now the line conventions. The line conventions is also most important to identify what it means. The first one is nothing but a dark line, or it's also called as a continuous thick line, which is a visible outer line, or it may be a visible edge. The second one is a thin line or a continuous thin line, which is an imaginary line, or it may be a projection line or a dimension line or a leader line. The third one is a dotted lines, a dashed thick line or a dashed thin line, which is representing the hidden outlines, or it may be the hidden edges. The fourth one is nothing but the chain thick. The chain thick represents the indication of the line or the surfaces to which the special requirement applies. Normally these type we are using in the case of the sectional parts, or it may be in the sectional drawings. The chain thick or thin at the end and changes of direction. This is also one of the way in representing the cut sections. Now coming to the line conventions, here there are two drawings. One is with respect to the cube, the another one is with respect to the cylinder. The outer part is represented by a dark line. The inner part is represented by a dotted line. The inner part is represented by a dotted line is because of the what we can say the hidden edges, or it's also called as the invisible edges. The another one, which is nothing but an axis is represented by means of a dash and a dot. By looking into these sketches, here only we are represented by three different types of line. One is a continuous line, the another one is a dotted line, the another one is a dash and a dot line, which is representing it as an axis. Now even while representing an arrow we have to go with respect to the dimensions. The arrowhead dimension, it should be 1:3. If the width of the arrow is 1, the length of the arrow, it should be 3. In this sketch there are what we can say the two sketches are there. One is with respect to the three-dimensional sketch, the another one is with respect to the two-dimensional sketch. Even while representing the arrows also, there are what we can say the three different types of arrows it can be used. One is a open head arrow, the another is a closed head arrow, and closed and filled head arrows. Now before going into the regular topic, first we will understand the scheme of evaluation, and then afterwards we will go in detail with respect to the each and every module. The module 2 is between the lines are the planes, which is for the 25 marks. The module 3 is for the 45 marks. The module 4 or module 5 is for 30 marks, put together is of 100 marks. The question 1, which is nothing but the lines are the planes which carries 25 marks. 25 marks is the 15 marks is for the solution, the another 10 marks is for the computational work. The module 3, which is nothing but the solids, is of 45 marks, where 25 marks is for the sketching, the another 20 marks is for the computational. The question number 3, which is nothing but a development of surfaces or development of lateral surfaces or the isometric, which is for the 30 marks. In that 20 marks is for the sketching and another 10 marks is for the computational. Put together is of 30 marks. Now by looking into this, the sketching consists of 60 marks, the computational consists of the 40 marks, put together is of 100 marks. We will know something about the orthographic projection. Now in this orthographic projection, we will learn principles of projection, objectives of the projection, orthographic projection, principal planes of orthographic projection, the 4 quadrants and orthogonal projection, first and as well as the third angle projection. The principle of projection. When an object is introduced between the light source and a screen, a picture will be casted on the screen. This picture is called as the projection of the object. Now there are 3 entities. One is the light source, the another one is the object, the another one is a screen. The light source is indirectly what we can say as an observer. The object, it will be an object. The screen is nothing but the plane where the image of the object is casted on the screen. Now the principal planes of orthogonal projection. Sometimes a single plane of projection would be sufficient to describe the object, but a 3D object is to be defined completely at least by a 2 views. Generally we consider the 3 views and hence it is called as the 3 planes of projection. The first one is the vertical plane, second one is the horizontal plane, the third one is the profile plane. Even in the profile plane also there are 2 types. One is a right profile plane, another one is a left profile plane. Now here the object is nothing but the matchbox which is placed inside the 3 planes. The first one, the opposite to the object which is nothing but a matchbox, is nothing but a vertical plane. Below the matchbox is the horizontal plane. To the left side of the matchbox is the profile plane. Once if the observer is looking in the front view, the image what it is transferred on the vertical plane is nothing but the front view. The side portion of the matchbox is viewed through the right side, but the same image is transferred to the profile plane, which is nothing but a profile view. The same matchbox, if you are looking from the top, the image of the top view is placed on the horizontal plane. That image is called as the top view. The 3 in the right side, all the 3 images are transferred to the particular planes. On the vertical plane, front view is there. On the horizontal plane, the top view is there. On the profile plane, right side view will be there. The principal planes of the orthographic projection. The vertical plane fixed. It's a vertical plane in front of the observer. View on the VP is a front view and it is also called as the front plane. The horizontal plane, which is nothing but a rotatable, it's a horizontal and perpendicular to the vertical plane. View of the HP is a top view, or it's also called as the top plane. The profile plane, which is also a rotatable, it is also a perpendicular to the vertical and as well as the horizontal plane. The view of the PP is the side or the profile plane. Which side it is lying is also most important. In general, what we can say, it is also called as the profile plane. It's also known as the auxiliary vertical plane. Now the rotation of the planes is also most important. That depends upon the type of the projection. Either it may be a first angle projection, or the second angle projection, or the third angle projection, or even the fourth angle projection. The four quadrants. A point may not always lie in front of the VP and above HP. As we extend the planes beyond their lines of intersection, we get the four quadrants. As you know that even in the mathematics also we are dealing with respect to all the four quadrant, first quadrant, second quadrant, third quadrant, and as well as the four quadrants. The first quadrant is nothing but above HP and as well as in front of VP. The second quadrant is above HP and as well as behind VP. The third quadrant is below HP and as well as behind VP. The fourth quadrant is below HP and as well as in front of VP. The symbolically representation of the quadrants, it can be represented as above HP and in front of VP it can be represented as a line XY. Above is HP, below is VP. The same way the second quadrant, above HP and as well as behind VP, it can be represented as XY, above only VP and HP in the bracket. The third quadrant, below HP and behind VP, a line XY, above one is HP and below one is VP. With respect to the fourth quadrant, below HP and in front of VP, a line between XY, below HP, within the bracket VP. The representation, the first quadrant and as well as the third angle projection. Now, as we have discussed in the previous slides, where the top view and as well as the front view, the top view it will be on the HP and the front view always it will be on the VP. If you take an example as the first angle and as well as the third angle projection, where the top view is on HP, the front view it will be on VP. But if you consider the other two, either it may be the second quadrant and as well as the fourth quadrant, both HP and VP, or the top view and as well as front view lies on the same side. It is very difficult to identify which one is the top view and as well as which one is the front view. For that reason only, we are referring only the first angle projection and as well as the third angle projection. But now what we are discussing is with respect to the first angle projection only. Now the first angle projection. The first angle projection representation is nothing but the front view it will be towards the left side and the top view towards the right side. The object lies in between the observer and as well as the plane of projection. The front view is above XY line, the top view is below XY line. The right side view it will be on LPP and the left side view it will be on RPP. But in the case of the third angle projection, the top view it will be on the right side, the front view it will be to the the top view towards the left side, the front view towards the right side. The plane of projection lies between the object and as well as the observer. The front view is below the XY line, the top view will be above the XY line. The right side view will comes on the RPP and the left side view will comes on the LPP. Thank you.